There's something about negative exponents in an equation that just gets under the skin of some college algebra students, so thought I'd better do one of these. Let's solve 2x to the minus 2 minus 7x to the minus 1 plus 3 equals to 0. Okay, now there's actually a couple ways to approach this problem. Let me just approach it as it's written. It is a quadratic form, and we would factor, if we can factor, we would factor with x to the minus 1. Because this is minus 1 squared, x to the minus 2. So 2x minus 1 times x minus 1 is 2x minus 2. And the middle term is x to the minus 1. We need 1 and 3. And let's see, they're both going to be negative. So you can check that factors correctly. This is minus 6, minus 1, here's minus 7, plus 3. So we would set each factor equal to 0. And, well here, if I add 1 and then divide by 2, I get x to the minus 1 equals to positive 1/2. And here x to the minus 1 equals to positive 3. And now the moment of truth, what do you do with that? Well, x to the minus 1 is literally 1 over x. And so to get to x, we would just invert both sides. Here x equals to 2, and here x equals to 1/3. There's your answers. So there's a rather direct approach to this problem. All right, now we could try some other things. For example, I'm going to erase all this stuff and show you a little bit different approach. We could just change the negative exponents to positives at the outset. So that would be 2 over x squared minus 7 over x plus 3 equals to 0. And we could factor with 1 over x, or you could clear the variables. I'm sorry, clear the fractions. So if I multiply by x squared, here it cancels. I have 2 and then minus 7x plus 3x squared equals to 0. And if we reorganize this, it'll be easier to factor. 3x squared minus 7x plus 2 equals to 0. And now we factor 3x, x, 1 and 2, both negatives. And from here we get positive 1/3 and positive 2, which were the answers we got earlier. Okay, I know I did this very fast. You may, if you need to, pause the video and make sure you followed all those steps. Hopefully it's very routine stuff there. The main thing I wanted to show you is that we could eliminate the fractions and then proceed to solve it as an ordinary quadratic equation. Finally, there's another approach that's just almost identical to this, except I'm going to skip that step and immediately multiply by x squared, because I see that x squared times x to the minus 2 is x to the 0 power. It cancels, leaving 2. And x squared times minus 7x to the first would give me a minus 7x to the first. X to the negative first, I meant to say, then minus 7x to the first. And then here, of course, here's your 3x squared. So this way of doing it leads you immediately to that step. So anyway, don't be too concerned with the negative exponents. You can change them to positive, or you can eliminate them in various different ways, because they are ultimately just fractions. So now, if your exponents are fractions, that's a different matter. And I'm going to erase the board, and I'll put up another example for you. Here we have an equation with negative exponents and fractions. So let's look at it. Solve x to the minus 1/2 plus x to the minus 1/4 minus 4 equals to 0. What a mess. Okay. Now, again, with these, there's several ways of looking at it. We could decide to factor it with x to the minus 4, 1/4. That would work. Or we could eliminate the negative exponents by multiplying through. There's a couple ways to look at it. And so let's eliminate the negative exponents. I think that would just make it easier. So now how would you do that? Well, the least exponent up here is negative 1/2. I mean, look on the number line, negative 1/2 is less than negative 1/4. So I'm going to multiply by what cancels that, x to the positive 1/2. And so doing, it's going to eliminate this exponent. It's going to turn that to a positive, and we'll get a positive exponent there. So when I distribute the x to the 1/2 here, it's going to cancel here, leaving x to the 0 or 1, and then I'll have 6. So there's 6 plus 5, and then add negative 1/4 to 1/2, we get positive 1/4, and then minus 4 times x to the 1/2 equals 0. All right, so that's marginally better. Now we could rearrange this in descending powers. This is the highest power, but it's also a negative exponent, a negative coefficient. It would be awkward to factor it that way. So I'm going to, and we could factor it the way it looks. You could do that, but I'm going to turn this into as much of a quadratic form as I can. So in essence, I'm going to change the signs of these, multiply by negative 1, and then reorder it. So I end up with positive 4x to the 1/2, and then minus 5x to the 1/4, minus 6 equals to 0. There we go. So here's our quadratic form, and in fact it's 4 times x to the 1/4 squared minus 5 times x to the 1/4 minus 6. In other words, here's the squared term, here's the linear term, and there's a constant. And so if we go to factor, we factor with x to the 1/4. So I will use x to the 1/4 as my base variable. And let me see, if 4 is, I don't think it's going to be 2 and 2 because this is an odd number. So I think it's going to be 4 and 1. So let's call that 4 and I'll call that 1. And 6 is probably 2 and 3. Let's see if we can get this factored correctly. So here's 4x to the 1/2. There's 8 and 3. To get negative 5, I need negative 8 and positive 3. So negative 8, positive 3, x to the 1/4 is negative 5x to the 1/4. And then plus 3 times minus 2 is minus 6. All right, so it's properly factored. And I'm going to straighten up this negative sign here, minus sign. All right, so I need to make some room here to finish. And so set each of these factors equal to 0. So 4x to the 1/4 plus 3 equals to 0. And x to the 1/4 minus 2 equals to 0. Now, that doesn't have an answer, does it? Because what is x to the 1/4? It is the fourth root. It's an even root. And remember that, well, we can solve it with complex numbers. It's a mess. So let's go ahead and see if we can do it with complex numbers. If I subtract 3 and divide by 4, I get x to the 1/4 equals to negative 3/4. And I see that I misspoke. You can't solve this. There's no solution to this because a fourth root is never a negative. And so there is not at least a recognizable answer there. So fourth roots by definition are always positive, and so this is going to give us contribute no solution to the problem. So it's just like having a square root equal to a negative number. Square roots are supposed to be positive numbers, not negatives. But here, this would be okay because if I add 2 to this, I have x to the 1/4 equals to 2. And to solve for x, we would raise both sides to the 4th power. So x would equal to 16. So that's our tentative answer. And I'm pretty confident it's going to work in this equation. So, but you can check it. You can check it. Well, let's go ahead and check it. So, because it's always a good idea to check answers in equations involving square roots or fourth roots, even roots. And all right, so to check it, because the process of solving can introduce a false answer. We have 6 times 16 to the minus 1/2 plus 5 times 16 to the minus 1/4 minus 4 equals to 0. All right, now this is 1/2 power square root, and the negative makes it reciprocal. So square root of 16 is 4. Negative power makes it 1/4. So I have 6 times 1/4. The fourth root of 16 is 2. The negative makes it 1/2. Inverts it. So this is 5 times 1/2 minus 4. Now 6 times 1/4 is 6/4, which is 3/2. So this simplifies to 3/2. 5 times 1/2 is 5/2. And 3/2 and 5/2 is 8/2. This is 4. 4 minus 4 is 0. So this one does check out. And we can be confident of our answer of 16. So there it is. It's an awkward problem, I think, for a lot of some of you out there who are not used to dealing with exponents like this. And but keep in mind a couple of things. The negative exponents means they're fractions. They're inverted. And the fractional exponents means they're some kind of radical, like in this case, square root and fourth root. So keep those in mind and do a lot of practice.